Okay, quick video notations. Suppose you have an equation y equals x to the power of 3 here. The derivative of x to the power of 3 is 3x squared. You just have to take my word for it that when you work out the gradient of this, it will give you this. Just take my word for it for the time being. So the derivative of x to the power of 3 is this thing here. Okay, and sometimes you're given something like this, and then you're asked to differentiate x to the power of 3. So when you differentiate x to the power of 3, you will get this. Okay, so the derivative of x to the power of 3 is this thing here. The derivative of x to the power of 3 is this thing here. Um, you might be asked, differentiate x to the power of 3. Okay, so that's asking you to find the derivative of this thing here. Okay, so there is a slight difference, and that you may be given an equation or you may be given a function. So sometimes you're given a function like this, and then this is a notation that we use. Remember, notation means just the way you write things. It's just a convention that we use to write things. So the function is this. This here is f prime of x. So this thing here, f prime, means well, it's you differentiating it once. Okay, suppose you were to differentiate it again, then you would use f double prime. Suppose you want to differentiate it twice, so you would have to do this: f double prime, f double prime, f double prime of x. Then you would differentiate this again, which would give you 6x. Okay, but don't worry about how I got the 6x. Just take my word for it for the time being. And then you could use this if you wanted to, and so on. But don't go beyond 3. If you want to if you want to differentiate it 4 times, then start using this, of x equals blah blah blah, or f, and then differentiate it 5 times. Then you would write this. Okay. So there are 2 ways of doing. There are 2 ways of expressing the gradient. One is to use dy by dx, and the other one is to use this notation. So this notation is good for functions. This one here is if you're given an equation, then use this. Okay, and also if you have a function here, the purple line represents a function. Just say f of x here. And say you've got 2 points on that line, A and A here and B here. The secant line is the line that joins A and B together. So this is your secant line. The tangent is the line that just touches at point A. So suppose you want to know the tangent. Suppose you want to know the tangent at A, then it's a line that just touches A. So the secant line is the one that will join A and B together regardless of where A and B are. You're just going to draw a straight line. That there is a secant line. The tangent is the one that, suppose you want to find out the tangent at A. The tangent is a line that just touches the point A. Okay, so that's the difference between secant and tangent. Okay, and the other thing is, suppose you have a function f of x here. The average gradient is when you get this height divided by this length here. So the average, so you could have a function like this, something like this. You see, the gradient here is really steep. The gradient here is negative. The gradient here is really steep, positively steep. The gradient here is negatively steep. But overall, the average gradient would be this here. So you would just somehow get the height divided by the width here. That would give you the average. Suppose you have a function that does something weird like this. You see, your function here may be steep here, but then this suppose it's negatively steep here, and then it gets cancelled out with this this positively steep gradient. But overall, the average gradient would be the height over this. So when you get the height here, which is this thing here, divided by h here, then you will get the average gradient. But then if you want to find out the true gradient, then you would have to take the limit as h tends to 0. And sometimes we use this word instantaneous. It means the precise gradient at a particular point. So instantaneous means precise. Well, if you want to find out the precise gradient, or if you want to express the precise gradient, you would have to take the limit of this thing here. Okay, and sometimes we use this instantaneous means a precise gradient. Average means, well, it means the average between A and B. So instantaneous means the true gradient. Okay, the true gradient. And suppose you have a function here. Let's say you've got this function here, 2x squared minus 3x minus 5. You know the gradient can be expressed as the height here divided by this thing here. That's why you. But by the way, up here, this here is your average gradient, and the minute you use dy by dx here, this means the precise gradient, okay, or the instantaneous. This here is just the average, so there's a difference. The average is, well, the average is the average between A and B. Instantaneous means the precise gradient at this whatever point you want. So you can use instantaneous rate, or you can use dy by dx. The minute you use dy by dx, it means instantaneous. Okay, and going back to this here, yeah. So the dy by dx is really the height here divided by this thing here, and then well, you take the limit of dy by dx. But the thing is, this can be written as this: d and then over x here, and then the y here. So suppose you want to find out the gradient at A here, you could actually write it like this. Normally you would get this. So hang on. What my point here is, hang on, bear with me. Sometimes it can be written like this, meaning that if you want to find out if you want to express the gradient, you can do this here, d and then dx, and then write the function in here, 2x squared minus 3x minus 5 here. This is, you see, this is just another notation. This is an operate. This is something that you act upon a y value here. So this is just another way of writing the gradient. This way of writing things here is the advantage of this way of writing is that you can express y, so people actually know what the function is by doing like this. You see, you could just write dy by dx. That yes, people will know that this here is a gradient, but they don't know what the function is. So, but here's another way of doing it: d by dx, and then you write the value of y in here. And this is just a notation. It's just another way of writing this. This is also expressing the gradient. But the advantage of this method is that you get to see the function here by saying dy by dx. People will just know that you're talking about the gradient, but they don't know what the function is. But here, here you're just remember that this thing here is it needs to act on something. So you have to give it something here. In this case, is the value of y here. But this here this here acts on something. Okay, so you have to give this thing here some. Well, also another way. If you want to differentiate it twice, then you would write it like this. And don't worry if you don't understand this. Don't worry if you don't understand this. And this here needs to act upon something. So you could write this here, 2x squared minus 3x, this here. So that means this whole thing here means differentiate this twice. Okay. So if you differentiate it twice, well, don't worry if you don't understand this, but just remember that you could write this and then you act on something here. Again, don't worry if you don't understand this. When I give you some problems, then you will see. Then you will understand. Okay. Okay. Okay.